So in question 5, this is such a cool question. I love this question. So in Q5, you're given a function 1/3 x cubed plus rx squared plus x. So right away, I can see that this is going to be a cubic function, and it's got a positive coefficient. So it's going to look something like that. Find r such that the function has a critical point at x equals 1. That means where it's either going to have a point of inflection or a max or a min. This means that the derivative at 1 is equal to 0. So what we're going to do is we're going to set the first derivative equal to 0, right? So f prime of x is going to be equal to 3 times 1/3, which is x squared plus 2rx plus 1. Now, we know that f prime of 1 is equal to 0. So when we put 1 in for this, we're going to get 1 plus 2r plus 1, and that's equal to 0. So now we're going to have 2r is equal to -2, and r is equal to -1. So what that means is that this is this derivative is a parabola, but what the r means, going back to the original equation here, is that when this r is -1, this function has a critical point at x equals 1. So we're going to see that r is equal to -1. So to find the tangent line with the smallest slope, that's the second question. So the first question is, first you find the derivative, you set it equal to 0, you solve for r, and you get r equals 1. The second part is really interesting because we want to find the tangent line with the smallest slope. So notice that this derivative is a parabola. It's a concave up parabola, x squared plus, this becomes, now that we put the r in here, right, that's going to become x squared minus 2x plus 1. So we know from pre-calculus that the range of this, so in other words, you could use, for example, the, if you know it's a parabola, remember that the vertex of a parabola is -b over 2a, comma f of -b over 2a. So when we do that, we're going to get the x-coordinate is going to be -2 times a negative divided by 2 times 1, which is 2. So that becomes negative times -2, or 2 is 1. So what that means is that the x-coordinate for the vertex of the parabola that is the derivative of the original function lies at 1. Or another way to say that is that what we have here is a function, and as I said, we have here that the original equation occurs, the vertex occurs at 1. When we put 1 into this equation here, we get 0. So the vertex of the derivative is at 1, 0. So it's going to look something like that. Now that's the derivative function. So what does this tell us? The derivative is positive for every value, and this can go over here somewhere, right? Every value of x, the derivative is positive. And so the derivative has a minimum at the lowest value is 0. So of all that, we can conclude that for all the values of x moving along here, for all the values of x, the tangent line has its smallest value when x is equal to 1, right? When x is equal to 1. So you can look on the app to find the question that I'm going to ask at the end of this video.